So Friday we learned about the formula for general term of a binomial expansion, which is t sub k plus 1 equals nck x to the n minus k, y to the power k. So because of this, we saw that the k value is 1 less than the term number. If you wanted to find the fifth term, k plus 1 would have to equal 5. Therefore, k is 4. K is always 1 less than the term number. N refers to the power on the binomial. X is the first term of the binomial that's being expanded. Y is the second term of the binomial that's being expanded. So question B here asks for the third term in the expansion of 4b take away 5 to the power 6. So using this general term formula, if we want to find the third term, k would have to be 2, because the general formula starts with t sub k plus 1. In order for k plus 1 to equal 3, k must equal 2. N is the power on the binomial, which is 6, so it'll be 6c2. Again, k is 1 less than the term number. The first term of the binomial 4b is raised to the n minus k. The second term of the binomial, which is negative 5, is raised to the power k. So this is what we need to work out to find the third term in that expansion. 6c2. 6c2 is 15. 4b is raised to the power 4. 4 to the 4 is 256. b to the fourth times negative 5 all squared, which is 25. So our final coefficient we found by multiplying 15 by 256 and 25, which is 96,000. b to the fourth. There is the third term in that expansion. So again, by using the general term formula, it saves you from doing all the expansions and then picking out what the third term is. Question C, in the expansion of a squared minus 1 over a to the fifth, which term in simplified form contains a, which means a to the 1? We're looking for the term that has the first power. So one thing I would do first is I would change that second term in the binomial to a to the negative 1. So using the general term formula, we know that n is 5. Right? That's the first, or that's the power on the binomial. So 5ck, the first term, a squared, is raised to the power 5 minus k. And the second term, which is negative a to the negative 1, is raised to the power k. We can do some simplifying here. For example, a squared to the power 5 minus k, will multiply those exponents out and get 10 minus 2k. This negative a to the negative 1 actually has two parts. The first part is the coefficient, which is negative 1, that's raised to the power k. And then you'll have the a to the negative 1 to the power k, which if you multiply the negative 1 and the k together, that'll be a to the negative k. If we put the parts together, that will give us the coefficient, which would be the 5ck part, as well as the negative 1 to the power k part. We can also combine the a factors together. When you multiply powers with the same base, you add the exponents and keep the base the same. That'll give us 10 minus 3k, because you have to add negative 2k and negative 1k together. When you multiply powers with the same base, you add the exponents. So for the two factors that have the base of a, you add their exponents together. 10 minus 2k plus negative 1k gives us 10 minus 3k. This is how we determine what k must be. We are looking for the term that, when simplified, contains a, which is a to the 1. The exponent on a must be 1. 10 minus 3k has to equal 1, the exponent on a. So if you subtract the 1 from both sides, you'll get 9 on the left. Add the 3k to both sides, so you'll get positive 3k on the right. Divide both sides by 3, and k equals 3. So now we've determined what the value of k must be, so that when we simplify this term, we'll get the term that is a to the 1. So now we can find out what that is by letting k equal 3 in the final expression that we wrote here when we simplified. It'll be 5c3 times negative 1 to the 3 times a to the 10 minus 3 times 3 is 9. Again, that gives us a to the 1, which is what we were looking for. But we also have to figure out what 5c3 is. So that's 10 times negative 1, because negative 1 cubed is negative 1a. So we'll get negative 10a. There's our answer. That is the value of the term that, when simplified, we get a to the 1, or just the a term. And it would be the fourth term of the expansion, because remember, k is always 1 less than the term number. So that would be the fourth term in that expansion. Right? This next one, how many terms are there in that expansion? So we learned that the number of terms is always 1 more than n. N, the power on 2a minus 7, is 8, which means that there would be 9 terms. The number of terms is always 1 more than the value of n. What is the value of the fourth term? So again, we'll use the general term formula. T sub 4. If we use that general term formula, k has to be 3, because 3 plus 1 will give you 4. K is always 1 less than the term number. So n, the power on the binomial, is 8, so it'll be 8c3. The first term, 2a, is raised to the 8 minus 3, and the second term, negative 7, is raised to the power of k, which again is 3. So 8c3 is 56. 2a is all raised to the power 5, which will be 32a to the 5th. And then the negative 7 is raised to the power 3, which is negative 343. So now we will multiply those numbers together to get our coefficient. So negative 343 times 32 times 56. Our coefficient is negative 61, or 614,656. A to the 5th. So there's the value of the fourth term in that expansion. That is definitely quicker than doing all the expansion and then counting your fourth term. And part C asks us to use binomial theorem to find the first 4 terms of the expansion of 3a plus 2b to the power 7. So the value of n is 7. So remember, there's two ways to get our coefficients. We can use Pascal's triangle if we want to get that symmetrical array of numbers, or we can use combinations to get our coefficients. The first term would be 7c0 as the initial coefficient. That's not going to be our final coefficient because each term in the binomial also has coefficients. But that's what we start with. So remember that the first term of the binomial 3a is raised to the power n. The second term of the binomial 2b technically is raised to the power 0. Plus, our next term will be 7c1. The power on 3a is decreased by 1. The power on 2b is increased by 1. That'll give us our second term. Our third term will be 7c2. The power on 3a is decreased by 1. The power on 2b is increased by 1. That'll give us our third term. And the fourth term will be 7c3. The power on 3a is decreased by 1. The power on 2b is increased by 1. All right, so to the calculator we go. 7c0 is actually 1. Calculator will confirm that. And that'll be multiplied by 3 to the power 7 times 8 to the power 7. So it'll be 1 times 2187, 8 to the 7th. And again, 2b all to the power 0 is also 1. Plus, so that next term, 7c1 is 7, which you can confirm on the calculator. 7c1 is 7. 3a all to the 6th. 3 to the 6th is 729. A to the 6th. And 2b to the power 1 is just 2b. Plus, the next term, 7c2 is 21. 3a all to the 5th. 3 to the 5th is 243. And 2b all squared is 4b squared. And then finally our last term, 7c3 is 35. 3a all to the 4th is 81, a to the 4th. 2b all cubed will be 8b cubed. And now we will just multiply everything out to get each individual term. The first one being 2187a to the 7th plus 7 times 729 times 2 is 10,206. A to the 6th, b to the 1. And remember that in most cases, especially when you have two different variables involved, the sum of the exponents always has to equal n in each term. N is 7, that's the power on the original binomial, and the sum of the exponents in each term will also equal 7. So the next term, the coefficient we found by going 21 times 243 times the 4, 20,412. A to the 5th b squared. Again, the sum of the exponents equals 7. And the last one, 35 times 81 times 8 22,680. A to the fourth b cubed, again, the sum of the exponents equal 7, the value of that. Okay? And that is definitely quicker than actually multiplying out that binomial, 3a plus 2b to the power 7, and then going back and seeing what those first four terms would be. Because you'd have to multiply them all out and then simplify, and then go back and get your first four terms. All right. We saw examples previously where we could answer these pathway questions by using combinations, or basically factorials. So if you're going from A to B and you're always moving closer to B, meaning no backtracking, we saw that you could do these first two by using basically repetition. Okay? Meaning, if you're going from A to B, and remember, you don't start counting until you move. So starting at A, we're going to go a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 blocks altogether. So they could be done in 11 factorial ways. But when we did this, we said there's repetition because there are blocks that are going in the same direction. There is 1, 2, 3, 4, 5, 6 blocks that go in the same direction, being north to south. And we said that you don't start counting until you move, and that's why I skipped the first one. If you count the first one, then you'd skip the last one. Because if no matter whether you go on the first, second, third, fourth, fifth, sixth block going north to south, you're already gone from the top to the bottom, so you wouldn't count the last one. So either way, you're missing one of them. And so when we're talking about repetition, there are 6 blocks that go in the same direction from north to south. So we would divide by 6 factorial. And there's also 1, 2, 3, 4, 5 blocks that go in the same direction, meaning from west to east. Again, skipping the first one. So that would be 5 factorial, which incidentally is 11c6 or 11c5. If you use the combination formula, NCR, 11c6 would be 11 factorial over 11 minus 6, which is 5 factorial, 6 factorial, using the NCR formula. So that matches our original statement here. And if you use 11c5, it would be 11 factorial over 11 minus 5, which is 6 factorial times 5 factorial. Same expression as what we started with. So there's actually 3 different ways you could get the answer to this problem. All 3 of them give us the same expression at the end, 11 factorial divided by, I'll have to put in brackets, the 5 factorial times 6 factorial. So no matter which expression you put in your calculator, you're going to get the same answer, which is 462. And as long as your grids are full and complete, with no restrictions, nothing missing, you can use this method. So we could do the same thing for question B, but question C is different. You've got that hole or that piece in the middle of the grid that a person has to go around. So you could not use this method to get the answer to that one. However, there's another way that we can get the answer to all of these questions, and that is using Pascal's triangle. So let's see how this works with Pascal's triangle. We're going from A to B, and when I write my numbers along this grid with Pascal's triangle, These numbers represent not how many blocks are being traveled, but how many routes are being followed. So starting at A, we'll put ones all across the top. Those ones represent, again, not the number of blocks that a person is traveling, it's the route that they're following.
Hi there.
Hi.
Do you mind if I get into swap wireless?
Nope.
Okay.
Go ahead.
Okay, thank you.
Yeah. So again, it represents the route that they're following.
Or would coming back later be better?
Come back in 20 minutes.
Okay, we'll do that.
Yeah.
Thanks.
So this one represents all the same path. The person is going from A, going to the right, going from west to east, just following that same path. So that's what the ones represent, the path that they're following. And the same thing going down the side here, the path that they're following, going straight down. We're not counting the number of blocks they're walking, but the path that they're following. So now we'll start filling this in using that same concept with Pascal's triangle. 1 plus 1 is 2. There's two ways to get there. You can go down, over and down, or you can go down and over. Those are the two ways you can get to this point right here. No backtracking is allowed. You're always moving closer to B. To get to that spot there, you can either come from above or from the left. There's two ways to get to the left, one way to get above, so that would give us a total of 3 ways to get to that point right there. And we can actually trace them out. One way would be over and down. That's one way. A second way would be down and over. And you should see what the third way is. The third way you can do this is over, down, and over. There's your 3 ways to get there. So it's fairly simple to see what those 3 ways are, but as we start getting closer and closer to B, it's going to be harder and harder to actually trace out all the different ways to get to that point. So we will just continue using Pascal's triangle. To get to this point here, you can come from above or from the left, so you'll add the 3 and the 1 together to get 4. We're just adding the 2 ways that you can come from to get to that point. To get to this point, you can come above or from the left, so you're going to add the 4 and the 1 together to get 5. 5 plus 1 is 6, 6 plus 1 is 7. And we'll continue. To get to this point here, you can come from above or from the left. 1 plus 2 is 3, 3 plus 3 is 6, and we continue with that pattern. 15 and 6 is 21, 21 and 7 is 28. So that 28 represents the number of routes that a person could follow to get from A to that point. 28 different routes. And we'll continue. Again, just adding the numbers together, following that pattern that Pascal's triangle follows. So this one here would be 84. And we continue. 70 and 56 is 126. 126 and 84 is 210. And then the last row, and then finally 252 and 210 gives us 462, which is the same answer we got using combinations. So this method of Pascal's triangle can be used to determine the number of routes that a person could follow to get from one point to another along a grid. Again, you're always moving closer to B, meaning no backtracking is allowed. So for question B, because it's a complete grid, we can use combinations in this case. To go from A to B, you're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 blocks. So that we could be done using 11 factorial. 3 of the blocks are going in the same direction, 1, 2, 3. And I mean, we can count the other ones going from west to east, but this can be done using combinations, meaning 11C3, which is 11 factorial over 3 factorial, and the other factor on the bottom is 11 minus 3, which is 8 factorial. And that 8 would represent 1, 2, 3, 4, 5, 6, 7, 8 ways of going from west to east. Okay, so this is one way to get this answer, and then we'll also go back and do it using Pascal's triangle. 11 factorial divided by 3 factorial times 8 factorial. And whoops. And I've got to change. I hit times there instead of divided by. So there we go. 165 ways, 165 different routes could be followed to get from A to B. So we should get that same answer if we use Pascal's triangle. Starting at A, these will be ones along the bottom and ones along that left side. Again, these ones represent the number of routes that could be followed. To get to that point there, we can come from below or from the left. So you add those two numbers together. 1 plus 1 gives us 2. 2 plus 1 gives us 3. 3 plus 1 gives us 4. 1 plus 2 gives us 3. 3 plus 3 is 6. 6 plus 4 is 10. 1 plus 3 is 4. 4 plus 6 is 10. 10 plus 10 is 20. 1 and 4 is 5. 5 and 10 is 15. 20 and 15 is 35. 1 plus 5 is 6. 6 and 15 is 21. 21 and 35 is 56. And we'll continue. We get the same answer, 165. All right, now for question C, we cannot use combinations for this because there's a piece in the middle that the person would have to go around. So we have no choice here but to use Pascal's triangle. So here's what it would look like. Starting at A, you'd have ones across the top and ones along the side. And again, those numbers represent the number of routes that could be followed. So the next row is no problem. We can just follow along with Pascal's triangle. 1 plus 1 is 2, 2 plus 1 is 3, and so on. For the next row, we can fill in those first two spots. 2 and 1 is 3, 3 and 3 is 6. However, if we go across to where this next spot is, there is only one way you can get to that point, and that is from directly above. Because there's only one way to get to this point from directly above, the number of routes will be the same. All these other numbers we got by adding the two places that we could come from to get there. So we added those two numbers together. There's only one way to get to this point. So the number of routes that would be followed would be the same as above. Again, these numbers represent the number of routes that are being followed, not the number of blocks that are traveling. But to get to this point here, you can come from above or from the left. So 4 and 5 is 9, and 9 and 6 is 15. So these first two spots, same as what we have been doing. 1 plus 3 is 4. 4 plus 6 is 10. And to get to this spot here, now you can come from above or from the left. So you'll add the 4 and the 10 together and get 14. 14 and 9 is 23. 23 and 15 is 38. And the last row is done normally. So there would be 90 different routes that could be followed to get from A to B. And in this case, we're going from A to C, but the person must travel through B. Again, you're always moving closer to C. No backtracking is allowed. So because the person must go through B, that means you can only go 2 spaces over to the right initially. As well, you can only go 2 spaces down initially. Because the person must go through B, and you're always moving closer to C, which again, no backtracking. 1 plus 1 is 2. 2 plus 1 is 3. 1 plus 2 is 3. 3 plus 3 is 6. So there's 6 ways to get to B. And now from B, we're going to move closer to C. So there would be 6 paths or routes across the top from there, as well 6 routes going down. Just like we had 1s across the top and the side when we first started. From B, we'll have 6 across the top and down the side. Those numbers represent the number of routes that are being followed. A route changes when you change direction. So these are all going in the same direction. To get to this point here, you can come from above or from the left, so you'll add 6 and 6 together and get 12. To get to this point here, you can come from above or from the left, so you can add 12 and 6 together and get 18. To get to this point here, there's only one way you can get there. That's from directly above. So the number of routes will be the same as from above. But to get to this point here, you can come from above or from the left. So you're going to add 18 and 12 together and get 30. To get to this point here, you can come from above or from the left. 12 and 6 give you 18. And then to get to C, you can come from above or from the left. 30 and 18 add together to get 48. So 48 different routes could be followed to go from A to C, but going through B first, and then going on to C. Okay? So, so I gave you those questions to work from last day. So if you're not done those, you could continue to work on those. Remember that you have a quiz tomorrow on chapter 11, and then Wednesday we'll go through that quiz. Thursday is your unit 4 exam. So I'll also give you your review assignment so that you could start working on that today if you wanted to as well. But you can start working on that to help get you ready for either your quiz tomorrow or your test on Thursday. All right?